We are going to have people coming in as the presentation starts. Ramzi is going to check the names because last time, a couple of times ago, we were hacked. So now he only allows people in by invitation. So it's important to have people with their names, those that want to join the presentation. Okay, today's seminar is going to be given by Professor Mounir Mabsout. Professor Mabsout is in the Department of Civil and Environmental Engineering, and he led a team of students to look at this abandoned quarry pond, and it was a very challenging and interesting activity. What I would like to say is that Professor Mabsout's expertise, in addition to his technical expertise, is to engage students and to make sure they are part of different field activities and that they contribute to society and to the environment. He is the founder of the Center for Civic Engagement, and he was also the founding faculty leading the summer student camp activities in the Department of in the Faculty of Engineering. And I hope that with this Edu-BioMed introduction, we can keep Dr. Mabsout engaged, because if he is engaged, it means there will be a large number of students behind him actively involved in different kinds of projects. Now, this project was a collaboration with the Department of Landscape Design and Ecosystem Management, but for the purpose of this presentation, we are focusing on what the engineering team did specifically. Please go ahead, Mounir. We're going to all turn off our cameras and mute our phones. If you can keep your camera on, and we are ready for your presentation.
Okay, I guess you can all hear me well. Well, thank you, Salma, for the introduction. And it's been a tradition when I'm asked, why am I here? I use one of my colleagues and friends from LDM statement. Once he was asked this question, why are you doing this here? He said, why are you in this meeting? He said, because Salma said so. So that was Rami's rate. So I'm using his term. I'm here because Salma said so, and I have to be here. So I'm working on this with the team. We are a team in the Department of Civil and Environmental Engineering who work with many of other teams. Many of you are representing them here. So I will go through that actually as we go, because our involvement in this project includes the various teams that we work with. So this is the title that Edu-BioMed like to put, and I liked it, so we adopted it: Transformation of an Abandoned Quarry Water Collection Area into a Biodiversity-Friendly Fund in the Jabal Musa Biosphere Reserve. So again, this is just the presentation, the part by the CEE team, Civil and Environmental Engineering, as Salma said. However, the parts where we dwell on the collaborations will also be noted in this presentation. I'm going to try to make this more like a storytelling. It's a technical one in many ways, but again, going into site visits, working with teams makes it more like a story that the lens itself, again, this is important. We as an education institution, we'd like to see how we can work and delve ourselves into more research and practice that relate to the community, and in fact to become more real and relevant to the community. In this case, I'm inviting you to meet the effective team here, the direct team that worked on this. There are 4 civil engineering students from the department who are doing their practical training this back summer. Then one of them, Salah and Vanessa, who joined us also as undergraduate civil student, senior student, 4th year graduating soon, to do the part which took all what we have done in summer and put it in a package to be able to do the modeling, which is actually the core of what we have done. There is Dima, who is always with us on so many things and worked with me on so many previously projects when she was a student, and now she's a lab engineer and assistant manager of our labs. She has been in full support of the team and myself as being the supervisor of this project. Again, this has been done in collaboration with the landscape, and I do mention it here very clearly because we work together to reach certain conclusions where we can use for our modeling of the pond. That said, we'd like to define the problem first. We did say that this is a pond that happened to be there, and I like to say it like happened to be there. It's not a natural one. It's dilapidated now, as you can see in the right picture, and this is due to the fact that this whole area was being used, or perhaps more of abused, by quarries. At the time it was permitted until the reserve was able to acquire and prevent any more further work, and this was stopped. So these are part of the remains on the left of the quarries that I think they will be kept as a signal of what they have done. But they are nice, actually. You know, they can be thought as a sculpture. However, to be able to do their work at the time, they used to have a high need for water to water and cool down their machinery. So they created this pond on the right, and you can see that there is still water in it here, depending on the season. But again, this was used for more of an industrial work. They used to cover it with the plastic sheets to make sure the water is held, and it was not intended to be used as nothing of natural connotation or something that would like to attract ecological issues like anything as birds or planting or anything. So the question that we were asked to do as a technical team in civil engineering is to try to find a way to rehabilitate this pond and revive it so that it becomes more viable for ecological for ecological use, and of course for the purpose of the reserve, that is to serve as a also as a place to visit or to use in a more responsible way. So this is a quick outline. We just saw the problem statement and the solution to be proposed, to be studied, some background and literature that we did. And then most importantly in this case, because we're going to a technical issue and we use technical data, we needed to do some documentation of what's available, like mapping and climatology documents, as well as try to collect data from our own, from our team, from sites, and do some experiment in the lab so that they will all feed back to this highlighted point, which is put it in the model that will tell us how can this pond be used as now a place which will collect water from all what is surrounding it, the watershed, with all the factors that will affect, and this will be done technically through a software, and we'll show some results. So this will be spelled out again in a storytelling, more like with pictures, graphics, rather than just text. So conclusive remarks and reflections will be interesting to say at the end what we have learned from this in many ways. So then, as a background and literature, I would like to say that what Salma was saying about us in the department or in the Center for Civic Engagement, and interestingly also with LDEM, we went into a similar experience. Perhaps it was larger in a scale of the pond, but then more limited to the technical work. It was to try to rehabilitate another pond, which was the village pond of Marwahin. That was not dilapidated in a sense, but it was no more of use because of the way it was treated, and people were not more interested in it because they did not have water in it. We looked at many of the Jabal Musa archives. We had to search for different maps in different domains, and we had some help here from one of the experts here. He is also attending, Sharif Tarhini. Actually, Dima Hassani of the team is also attending here. There were many other resources. I'm not going to just dwell on them here. They're all here, just the regular technical documentation, some literature in terms of research papers, etc. But I'm going to just show for the fact that we're not new to this, and this is important because we learned from previous experiences to try to do our own. Once we were asked to do this, we immediately recalled a case of the village of Marwahin, which we did actually in 2011. And this was with the Center for Civic Engagement, the Department of Civil and Environmental, and LDM. And of course, it's always with partnership with the municipality of Marwahin and UNDP to support and fund it. And this is the status. You can have, although this is a much bigger scale than the pond we have here, but you can see the same features, like it is just left there. It will seep all the water it has. It's not being in use actually. And we went into a full study of the pond itself as a structural, as a geotechnical issue, and with the watershed that would come from the village. It was not here from the mountains, but rather from the streets of the village, and how can they feed, including the rainwater. And then we did the study and we developed this into a new and more developed pond. And you can see here all the works that were done. And this was done by us as a participating university with the municipality and with students involved after we completed the design, including, of course, the Center for Civic Engagement people there. And with landscape working with us, because we had to work also on the area surrounding the pond to become also viable for life for the residents of the village. So you can see here that this is the status of the pond afterwards. This was filled in winter. This you can see it in late summer, where you still have people trying to still take this water. And in fact, it did a lot of impact, and we have this documented. These were actually coming from different villages, not from the same village, and the municipality made a system. So it was a very much engaged project that we did, and we thought that this is something we would like to do, and this actual project, Jabal Musa, came in the same direction. So this is a quick story for just to know that it's interesting to do this project and they become real, and we can see here what is happening to this pond. So what did we start with? Well, we had to go through some documentation and data collection. There are some available documentation, like we had some geographic maps of Jabal Musa in AutoCAD in different forms. We looked at them, including in the pond location. We did need some climatology data, which was not available easily, like weather and rainwater. We did that for 5 years. And really, this is a very tough situation we would be in such areas. They are not all documented well. We had to look into army, into meteorology's centers, other centers, individuals, and they were really hard to obtain, but with some help and some connections, we got as much as we can. They were not enough. Some of them were not very accurate or not precise to the need that we have to use for our own modeling later. So we did also further data collection. First, we did work with the LDM, of course, to try to find, to make a layout of the design of the pond on its area, because we needed to have it finalized in terms of geometrical shape, the volume, the dimensions. Site visits for exploration to get the feel of the thing, and surveying the site to get more accurate geographical mapping. And of course, soil sampling to get the actual data of the soil that will be used. And this will be detailed in quick here. So first, as for the design layout, there were many meetings between us as the two teams, the students, the supervisors, myself, Dr. Beata, and others involved with our both teams, and to come up with a layout of how this pond would look like, if you want to keep it the way it is, if you want to dig into it further, and what is it, how will be the surrounding, including, like you can see on the left, some terracing that will lead to the pond, so that whenever this fills, it will have terracing so that that can be used as platforms for different kind of species, birds, and also to be able to have different kind of planting, aquatic or none. And this is, again, not our specialty, but it was a great experience that we also as civil engineers had to learn the trade, because we live in a small world now. We all work together, and this is part of the interdisciplinarity of this project. So this is a draft or a final layout of the actual, it's a profile, a cross-section. It is like, it should be thought as a volumetric cross-section, but this is just one section, which we needed to also input into our model. So this was the first part. Then in site exploration, it was meant first to try to have a feel, of course, not just for a quick visit, but so we did also look at the things that were happening and how this site looks like as a whole. But then also we focused on the pond, which is the area on the left, and what's surrounding it, because our study would like to see how this pond can fill in water from rain, from all whatever is surrounding it, like the mountains or the terraces around it. So this was the visual effect, of course. And then we had to do also some surveying. So this is where the teams is active in the manual surveying. This is like the quick surveying to get the basic dimensions that will help us to make sure that we know exactly where the pond is located, so that we have the basin well defined between its dimensions and depth and actually shape. So there was some work done manually, as well as, which was probably more interesting, not because the manual is not important, because these are the new technologies that help us do things in an accurate way. And we have done it actually in two different ways. This is just the one we did with our own team, our own labs in the surveying lab with Dima's help. Dima is our, again, assistant lab manager. And using some special devices for scanning, three-dimensional scanning. The important thing maybe here is the same. We had actually 6 scans, 6 locations. The machine was put and it scanned in a rotation of 360 degrees to get the full picture of the area. This is an interesting point which Dima mentioned to me, is that this is tell you how many points in terms of the sensitivity of this scanning. 175 million points were tracked to give us a good figure of the scan and of finally the geographical layout. These were the 6 points, just to tell you that they were picked here. The one in blue is inside the pond, and this was done at 6 times with 6 of these rotating fully to get you the full picture of that. This is one sample of how the scan figure looks out, the picture of the scanning. It's quickly animated here. So you can see here that the machine is rotating and getting this. Of course, this is just now a video, but from this video, and seeing the picture on the small picture on the left, the orangish one, this means that you have been looking at the whole site, and then this will digitize those into layouts that I put one video here to show you the layout, but it was hardly showing, but you will see this more in a CAD format that will be tracked and then digitized to give you the dimensions, levels, etc. that you need. So these were enhanced tools so that we are also able and further to document our geographical map with whatever was available to make sure we have finally a precise digitization and geographical 3-dimensional representation of the pond and the surrounding area. That's the important thing, is that we could always work with the pond itself manually and do things manually with manual surveying. But because we needed to have the whole picture, which will enter into the model for our watershed, these were the tools that were used. So from this, for instance, this is one data that we could extract. This is showing from the model and the scanning and the digitization, this can show you in different segments the levels that were obtained, because this is exactly what we will need, other than the nature of the soil and nature of vegetation and rocks around, but the levels of these. So this was done at all levels, at all points, to try to track all those levels so that our maps become more and more accurately digitized. So this is about the surveying. The soil, I think this is now on more technical level. We needed to get the soil properties, characteristics, because first we need to understand its features. We need to know what is the soil beneath the pond and the surrounding. This is for usage for the model. Also, like if you have a soil that is impermeable or permeable, you will get the data for its infiltration as it runs from the hills to the pond or inside the pond. There were many quantitative properties that we had to look at because they will also enter into the model, and also because they'll be needed for many purposes, whether now or later. So we did the conventional typical lab test from the soils data obtained, including the typical gradation, the porosity, the plasticity indices, which are important, and also the permeability that was extracted from this data. Just to have some pictures of the people at work digging into the ground, and this was done effectively as field work. And this is again part of the game, is to really be on site and do the thing as they are done in real life. So this is one kind of soils tested. This is the gradation to tell you that you have this much sand, silt, and gravel and clay, typical of any kind of soil, using what we call the sieve and hygrometer analysis. I did not show the other pictures. We have so many of these for different properties that were used effectively in our own model. Then I would go now to the probably the core of what we needed this for. What we did is we were compiling data, with all what we had seen, the available data, the obtained data from different sources like the climatology, the geographical data for making sure we know how our pond is featured in terms of its own geographical information, as well as the surrounding, all to be put in a software. And here, this will be now going through the part that will influence the software or the model or the rain catchment and storage that we wanted to know. So here you can see that I'm not sure if when I move the pictures, it will show, but I'm moving the pictures. 1 second. Okay, so okay, so this is like the typical hydrological cycle, which we want to actually investigate or have data of. We need to know what is the precipitation, which will affect the water. We need to know how much groundwater might infiltrate inside whenever it's running through the hill or inside the lake. We need to know how much evapotranspiration, because some of the water that is coming can evaporate, including the running water as well as the water stored in the lake, so that at the end, when from our runoff, which is depending on the slopes also, and the obstructions that you may have, which means like the trees, the rocks, all of it is entered into this model. And you will be able then to obtain from this how much storage would be stored in a typical lake. So this is a software which is called HMS program, which is developed by the US Army Corps. It simulates typical hydrological processes for different purposes, sometimes to get the flooding of an area, in this case to get the storage from the runoff, showing just a typical picture from the manual. But here we used it for our own. We have different data to be entered, including the basin model itself, the terrain data, and this all have to be entered in a digital. If you have it digitized, they can be entered automatically into the software. And then this will create the data that is needed to run the model with all what we have discussed of say, obstruction, runoff, losses, etc. So here, this is the famous files that you need to produce, which are the shape files from the GIS map. Again, our expert is with us here, Sharif. He helped us a lot in trying to capture these, whatever we had in data, to try to put them in these shape files that will be read. And the one on the right is actually the one on Jabal Musa. It shows you everything in what you need in this form. This is how the model will look like when entered with all what is surrounding it. And basically, once you have this and you have input all the physical data of the surrounding area or surrounding soil, and of course, again, the climatological data, which is the weather and the precipitation. you can have these entered again. This is just to tell you that the software has to give you all the data and will run. You have to enter all the features of the precipitation, as we said, and other data from the hydrological. And then you need to introduce the losses, which are given by two different methods. This means that you have to tell how much do you think there will be losses from, depending on the nature of the soil, depending on the infiltration, you can estimate the losses that will enter, which will reduce the amount of storage, whether from infiltration, whether from evapotranspiration, etc. So all of it entered effectively into the model will give you the results. I would like to say that here, the results are still in a raw form, they are still fresh. I was actually obtaining them lately, and we did not compile them yet in the practical sense. Like, we do have data, and it shows you over 5 years from all what we have acquired as data, what are the results of how much volume of water could be stored, evaporated, etc. And here I'm going to just show you the file that we have, and I'm just going to hint to you on what this may lead to. So you can see that this is from this year to that year, with all the data that was put in this year. So now we're using previous data to see what would have happened if the pond was rehabilitated properly, which means that we should have had already included in the pond some kind of layer to protect it from infiltration. This is for reducing the seepage. This is still tentative because we still have to agree with different teams, the landscape also, on what kind of pond we want to create, whether it will be concrete or whether it will be with some plastic fabrics or simply compacted soil with some enhancement layers so that it prevents its seepage. But then just to let us know that whenever you have this data entered, you can get such graphs which will tell you, for instance, here, this is the precipitation and the flow, and then you will get some kind of volumetric accumulation. All of these, again, to be interpreted so that we can give at the end that during the year, this is the fluctuation in level in the pond and whether it will sustain during summers or not. We have already explored a little bit, and we know that this is already leading to tell us that there will be a good water catchment. We can enhance it if we need, but I'd like to say that this is not yet finalized with the data that we have. But because we have the model now ready, if we want to make any changes to enhance, if we're not happy with the results, we can discuss. We can even create channels along the hills so that they accumulate water better, or we can work on the pond to make sure it does not infiltrate further. So I guess the story, I wish it would have ended with a nice picture of the levels of the pond throughout the year. But again, we had a lot of hard times to be able to reach the data from the summer till now, until we were able to do our own homework, our own extrapolation and interpolation of data from what is available and from what we were able to gather ourselves. I would end up with its conclusions and reflections, not necessarily on the technical level. I think the project is a conventional one for those who are doing any hydrological experience in a course or in a research. But because we were in an interesting area, because we were dealing with interesting features and interesting people, we were excited to do that. It really fed into much of what we'd like to do in research and education, which is leading to practice. So these can be intermingled in a way. And of course, being in an interdisciplinary mode with working with different kind of subjects and of course areas of specialties, this was quite enhancing to our knowledge and enriching to our experiences. The community engagement is important, the experiential learning where we use our own education to be part of what is going on in real life with partners that are most relevant to us. In fact, this is what I believe personally, that it should be a major component of the university mission and objective to become more relevant. It's not enough just to teach the classics that we do it well, but unless you do it in a way that puts people on site, let them learn from experiences, whether technical or community related, meeting with people, with partners, being on site. I think this brings a very important person experience, and it has positive impact on students specifically, on all of us. And we definitely experienced it here in this project with all the constraints that we had in COVID, in even sometimes we could not move because of the fuel, benzene, etc. But we still were able to produce the best we can at this point with the help from everyone. There are some acknowledgements here, of course, other than the team and everyone who worked with us. Sharif, thank you, you're here. Sharif Tarhini is a research assistant at the Urban Labs here at EUB. He's also a graduate student now at EUB in the Masters in Civil Engineering. He was the most helpful in getting us going with the GIS and mapping and be able to use the files that we had, which we didn't know what to do with, produce them in shape files that were useful for our model. Mario Mawaj, he's a research assistant at LDM. I never met him, but I communicated with him and the student worked with him. He was able to guide us on how to acquire best climatological data and then work with Sharif to produce what we need. We have many partners here, of course, LDM, NCC, APJM, and I would say I didn't put the rest, but the birds watching, our funders of Erasmus, including the university leading the job, and all others that I may have missed. I might say that because we could not complete things specifically on the modeling part in summer, it was actually the work that should be following what we have done in summer. There was some funding from MSAPA for work study. I would like to acknowledge those who did the modeling, Salah specifically, Salah Din, and Vanessa, both were listed at the beginning. So with that, I'll close it. I think you can see that this bird is not very happy, but I think this is nature. I don't know about birds a lot, so you may tell me. But I guess what we're doing here is to be, not other than being all friends with each other, I think we have to be protective and be partners, not only of each other, but of the people that live with us on Earth, whether the birds, the others, and as Selma calls them, the living plants, which are also living species, which I don't know how, but she says that they also live and feed. So that's my presentation to you. If you want to have any comment to our friend here, tell him or her what you feel, you're welcome.
Thank you, Mounir, for this very interesting seminar and for working through this difficult absence of data. I know we realize as a team how difficult it was for you to access the necessary data to be able to, and it sounds trivial, but really if one doesn't have baseline data, you cannot move forward. But I think with the work that you have here, we can have a very strong educated guess as we move forward. I would like to, if Beata, if you are willing, I would like to give just a couple of minutes for Beata, just to give an idea of the landscape dimension of the project. Here, the focus of the seminar was the engineering work and the research and the activities that the student did. But just to let everyone know that hopefully we are going to move forward as a complete team of engineers, landscape architects, and scientists with the Biosphere Reserve to put together a concrete proposal that is convincing that it is possible to rehabilitate the pond and contribute to biodiversity amelioration. Beata, would you like to say anything before we open the floor for questions and discussions?
Yes, so if I cannot, we had landscape students working together with with engineering students. And it was a very, very good collaboration because they've learned a lot. They were hesitating at the beginning, like what is their role, but then they found out that actually they are the best to put it together from different angles with the information, with so valid and so detailed information that was provided by our colleagues. Somehow the project, because we had internship, the internship ended, but we want to move it forward. And during our course now, we have natural landscape design course. Students are working also in Jabal Musa, and I'm pretty sure that one of them is going to pick the project and develop it as it should be developed. So we will have plan and intervention that can be done. In the same time, we were working also on using virtual reality tools. It will be another meeting, so I will not tell too much about it, but it was also a very interesting process. And I'm happy that it's not ended. I mean, that we will still have more input and design intervention that hopefully we can apply.
Thank you, Beata. I see Pierre has joined the meeting. Pierre or Rula or Mark, anyone from the Jabal Musa team, do you have any comments, any questions, inquiries?
Well, Salma, can you hear me? Yes? Okay. On behalf of my colleagues here, I just want to say, you know, we're happy, very thankful that this process has taken place within the Edu-BioMed. We're also very much interested in this to be sustained. You know, I mean, this project has taken place. It's almost ending, this Edu-BioMed project, EU project. But we want it to be sustained. We want to have some kind of output that we will both be very proud of at the end. So I don't know how this gets realized, but what I do know is once we have something workable and detailed, we can go out and try to get the funding for it. How long it will take and exactly what is required along the way in terms of also the actors and partners, because I think we need, of course, landscaping, but there still is some technical questioning about how to make this thing, whether there will be any water left in summer. If yes, great. If not, should we find a way to insulate or whatever? But also there's the issue of evaporation. All these technical issues. Sorry, I'm going into too much detail here, but I just wonder what will be the next step so that we get into something we can proudly feature as a joint achievement. Voila.
I'm gonna let Mounir answer because most of the questions you asked, Mounir indicated that they have a good idea of the capacity of the pond, and he was saying that now is the time to discuss whether we want to insulate and how to move forward, especially that I think also now with Beata students working on a class project, this is our chance to have a last push, working all together to come up with some kind of proposal document by the end of the academic semester. Mounir?
Yes, I think that what Pierre mentioned is exactly where I ended, to say specifically that without having all of this work materializing into a tangible product, that is to say, with this kind of setting, with this kind of data that we have, with this kind of data or design that we will implement, we will or will not have the water all through, or we need to enhance it. I think we have reached the major milestone which we had problems with before. To make sure that we are able now to put all of it in the model, we have to really get the data to be acquired, other than learning how the model works. This was an experience on its own, but this is technical. The issues with it are certain, which we were able to acquire, are there. We will now have to just interpret what we got to make it a very easy to tell story that this is what we will have throughout a typical year from the 5 years that were before us. Because again, we cannot predict what comes next. We can try to do the simulation for previous year, assuming we're going to get similar years. That's why we did over 5 years and not over 1 year, because it will go through the fluctuation. Yes, we will have to keep going on this, and then we let everyone know that this is what is accumulating today over the whole year, including summers and winters. And whatever we get, we will see if it's not sufficient, we will have to enhance it. But what you ended up with is almost what we needed to now be able to put the model into practice. This was quite a tedious job to do at some point, including the working of the model, because the site is not a uniform one. It was quite varied in terms of its natural settings. And I agree with you that there is this last step that we need to produce for you so that we can guarantee to the best that we can in our model that things will work. Otherwise, we can still work on making things even better in terms of the outcome with certain changes that we can do to the setting of the pond.
Mounir, that's just a question for the sake of clarity.
Yes.
So based on your preliminary data, there is capacity for water collection, for rainwater, for water harvesting into the pond. Now, the decisions that we have to make are related to the lining of the pond, right? And also, we need to go back and work again with landscape architecture and with biodiversity to understand the restoration of the area, correct?
Yeah, yes, we have to finally ourselves to give the results based on our own assumptions that can be varied with the teams.
Okay, because I remember that I think, Beata, correct me if I'm wrong, but this is the information that the landscape architects need to be able to produce a design. Is this correct, Beata?
Yes, definitely. Definitely, because we already produced some ideas, but we were not sure about if it's going to be feasible, if it's going to be sustainable. And the question was if we need to fill it with water or water that it's from the area, it's enough. And I think now we can finalize it and also work together with our colleagues from engineers to find out the best solution, because also this was the discussion, which kind of materials we are going to use and how to make a pond that it's going to be a live pond, not just a pond with water, but also with implementing certain biodiversity, also how to build it to not to create ecological traps, etc., etc. So I think we are in very good point now with all this information. And one or two of my students are going to take it over. They are working on strategy now, and in 2 weeks they are moving into individual projects. And I'm pretty sure that we will have final design as it should be, with more details and, as Pierre said, something that we can use to find maybe funds to build it. And actually, it's going to be great incentive for my students if they know that something they design might be built. So
yes.
So يعني to sum it up, by the end of this semester, Pierre, if because I know you enjoy the research and the activities that you do, but in the end you want to know what can be implemented so that we benefit from all this. So by the end of this academic semester, we will have a proposal detailing the water harvesting capabilities and designing the area and defining the level of restoration that will occur in the pond.
Salma, this is great. I mean, you know that we are transforming something that previously was something destructive and fairly ugly into something that can become extremely positive for biodiversity. Yes, definitely, we want to showcase something together and keep going with AUB on other stuff, hopefully in the future. So we very much look forward to this and to going out to potential donors or funders, funding entities to make it happen. Yes, definitely.
Okay, great. Any other comments or questions before we wrap up our session today?
Yes, I just want to thank everyone, thank Mounir, and this is a great initiative that is in the very spirit of Edu-BioMed and the spirit of bringing university out there. So to build this bridge between the academia and the territory, no? So thank you very much. I have works, as you may hear, next door, so I cannot say more because it's disturbing, no?
Okay, thank you, Antonio. Okay, thank you everyone for attending. The session is recorded, so anyone who missed it will have it available on the YouTube page of the project website. And Mounir, we will follow up with you and with the team in Jabal Musa and with Beata and Monica and I. We will need, I think, one meeting around the end of the semester to put together everything we have completed in this project and make it available to Pierre and his team. Thank you all for attending, and we will see you next week.
Thank you.
Thank you.
Thank you, everyone.
Thanks a lot.